This meeting is being recorded.
Okay, let's go ahead and get started today. Okay, the first thing I want to do is I want to cover the worksheet that was assigned. Some people had some issues with getting the correct answers, so maybe it would be good to go over that at this point. I'm not accepting any late work at this point, so yeah. So we're able to go over it. Okay, so let me pull that up real quick. Okay, hopefully everybody can see this. So let's see what's going on with these things. Okay. It says number one, a Kickstarter program. Make sure that I'm recording. Yep, I am. Okay. A Kickstarter program, a project on Kickstarter.com was aiming to raise $15,000 for a precision coffee press. They ended up with 714 supporters raising 557% of their goal. How much did they raise? So basically what we're asking is, what is 557% of 15,000? Okay, so I'm gonna move the decimal over twice. I get 5.57 times 15,000. Doesn't matter how many supporters there were. That's kind of erroneous information. It's extraneous information is what I should say, not erroneous. Extraneous information that we don't really need to solve the problem. It's just extra information. So 5.57 times 15,000. Feel free to get out your work and compare it to mine. Is $83,550. So hopefully that's what you got for number one as well. Okay, another project on Kickstarter for an iPad stylus was raised 1,253% of the goal, raising a total of 313. What was their goal? What was the original goal? So we want to know what's 1,253% of what is 313,490. Okay, so we're going to again move the decimal over twice, but this is now, the of means multiply and the is means equal. So I'm going to create a variable here for the what. I'm going to say that 12.53 times x is equal to 313,490. I'm going to divide by the 12.53. Let's see what we get when we do this. So 313,490 divided by 12.53. Okay, I'm getting about $25,019.15. So what was their original goal? I would say about $25,000. You know, anywhere around $25,000 to $25,019. It really doesn't matter how you want to round this here. So $25,000, $25,019. Okay, I don't think you need to go to the pennies, but you could. 25,019 and 15 cents. All three of these would be acceptable. Okay, express the relationship as a rate of change. Okay, so a lot of people did this one backwards. They did pounds per dollars. That's really not what happens when you go to the grocery store, right? When you buy some meat at the grocery store, you don't say I'd like, 1 pound, for 25 cents or whatever. I mean, you don't say I want, how should I say this? 3 pounds for $1. Or 3.27 pounds for $1. That's not how you do that. It's dollars per pound. You want to say, I'm going to pay $1.50 per pound. So if we're going to pay $1.50 per pound on something, then we really want the dollars to be on top and the pounds to be on the bottom. So 4 divided by 10 is 0.4. So this is 0.4 dollars per pound, or 40 cents per pound. That's pretty much how you'd find it in the grocery store. It's for 40 cents per pound. Okay, a crepe recipe calls for 2 eggs, 1 cup of flour, 1 cup of milk. How much would you need if you use 5 eggs? Okay, so 2 eggs, 1 cup of flour, 1 cup of milk. How much flour would you need if you use 5 eggs? I believe we kind of went over this one in class. But we have 2 eggs for every 1 cup of flour, right? 1 flour. Okay, so we could multiply, or we could cross multiply. We could get 5 eggs per X flour, X flour, right? So boom, multiply, this is 2X equals 5. So X equals 2.5 cups of flour. Okay, 2.5 cups of flour on that one. Okay. Number 5, a 3 megawatt turbine can supply enough electricity to power 3,000 homes. How many turbines would be required to power 55,000 homes? Okay, so once again, we're just going to set up a proportion here. So a 3 megawatt turbine, okay, so we really don't need a 3 megawatt. We just need to know that 1 turbine can power 3,000 homes. Okay, we don't care how many watts it is. That's, again, that's kind of extraneous information. Okay, so 1 turbine can power 3,000 homes. That means that X turbines can power 55,000 homes. Okay, so cross multiply 3,000 times X. Oh, is it 4? Is it 4? Oh, 4. Thank you so much. It is 4. Okay, 4, 3. I read that way too fast. Thank you so much. Okay, it is 4. So 3,000 times X is equal to 4 times 55,000. Okay, divide by 3,000. Okay, and X equals, what's this going to be equal to? 4 times 55,000 divided by 3,000. Okay, is about 73.3. So 73.3. So how many turbines do we need in order to get to the 55,000? Because if we only had 73 turbines, we wouldn't get there, right? Yeah, thank you, Alex. We would actually need 74 because we would make over the amount of power, but we still would be able to get to 55,000 homes. So we would really need 74. Even though this is 0.3, we round up because we have to have that extra amount. So 74 turbines, and make sure you put your units on these. Okay, I don't know if I've been putting my units or not. So yeah, this is dollars. Okay, dollars. Okay, make sure that you put your units. Okay. Okay, a car is driving, okay, 100 kilometers per hour. How far does it travel in 2 seconds? Okay, so 100 kilometers per hour. Okay, I want to know how many seconds are in an hour. Well, I think we went over that. There are 3,600 seconds in 1 hour, and I want 2 seconds, right? I want to multiply by 2 seconds. And how far does this travel in 2 seconds? Well, I could reduce this if I really wanted to and just go 100 over 1,800, right? Right, and then the seconds cancel with the seconds, the hours cancel with the hours, and I'd be left with kilometers. Okay, so what's 100 divided by 1,800? Okay, is about 0.5, 0.05, 0.5, or 0.05555 forever. Okay, now I don't expect everybody to know what 0.5 forever is, but it is 5/9. So if you wanted to change this to a fraction, you could. Okay, or you can just put a bar over the 5. It just goes on forever. Okay, but this really isn't how we would think about it. What is 0.05 kilometers? Anybody know what 0.05 kilometers is? think back to science class. Close. A kilometer is 100, right? Isn't that 100 meters? Right? It would be, it would be 100. So if I divided this by 100, right? This is, or if I multiplied by 100, right? Wouldn't the decimal move twice? Yeah, exactly. It's 0.05 into meters, right? Does that make sense? 0.05 into meters would be 5.5 forever kilometers, or wouldn't this be 5 5/9 kilometers, or sorry, meters? I'm doing it again. Okay, meters. Why? Because if we think about this, how many meters are in 1 kilometer? Well, there's 100, right? So we could do the same process here, right? And just go kilometers, cancel out the kilometers, and we'd be left with meters. And for me, that's a little bit nicer. Now, I would accept the 0.05 kilometers. However, it's nicer to be able to write this as a fraction with 5 5/9 kilometers. Does that make sense? And this is a little bit, it's just a little cleaner, right? Okay, it's just a little nicer, a little cleaner. Okay, and again, I wouldn't expect everybody to understand what 0.5 forever is off the top of their head. Okay, but if you did memorize that from 6th or 7th grade, 0.1 forever is 1/9, 0.3 forever is 3/9. Why is it 3/9? Well, it's 1/3. Oh, look at that. That works out nicely. So any number repeated forever is just that number over 9. So that's a little trick that you learn when you do a lot of math. Okay, what's 0.6 forever? Oh, that's 6/9, which is 2/3. So a little fun with fractions there. Okay, number 7, it takes an air pump 5 minutes to fill a twin size air mattress. How long will it take for a queen size air mattress? Okay, so here what we got to do is we got to find out the volume. Okay, and we have to compare minutes to volume. So let's first find the volume of the twin. So this is 39 times 8.75 times 75. Okay. So what is that guy? That's 39 times 8.75 times 75. So this is 25,593.75. Okay, and that's cubic inches. Okay, what's the volume of the queen size mattress? Well, that's 60 times 8.75 times 80. Okay, so let's see what that is. So 60 times 8.75 times 80. Okay, that is 42,000 I'm getting. Feel free to make sure that I'm doing this right. Okay, feel free to verify my numbers. Okay, 25,000. Okay, so now we want to know, set up a proportion. It takes 5 minutes to fill the queen size, or sorry, the twin. How long is it going to take? I'll just put X to fill the queen. Okay, that guy's 42,000. Let's cross multiply and divide. Okay, so 25,593.75. Okay, X is equal to 5 times 42,000. Okay, divide by 25,593.75. Divide by, okay, 25,593.75. And what do we get? we get 5. Okay, 5 times 42,000. Okay, divided by 593.75, and I'm getting about 8.2 minutes. Is that right? Or is that right? Yeah, 8.2 minutes. 8.2 minutes. Okay, if I subtract off 8 and I multiply that by 60, this becomes about 8 minutes and 12 seconds. So I would accept either of these answers. Okay, makes sense. Any question on this worksheet at all? Are we good? It's all good? All good in the hood? Okay. Okay. Sounds great. Okay, let's jump into today's, oops. Let's jump into today's material. Okay. Let's jump into chapter 3 here. Okay. Does everybody have chapter 3 notes? Did I share that with everybody? Does anybody need me to share it again?
I don't think you shared them. I don't have them.
You don't have them? Okay. I think I shared it last week, but I think people are having a hard time getting it off of the chat room there. Okay, so let me do that real quick. Go back to your bad self. Okay. You didn't receive them? Okay. So you want this as an email, or do you want this as a, well, let's try it in the chat for right now. I don't know. Hopefully everybody's here today. I'll have to take a roll. Email, please. Okay. Well, yeah, let's do the email. Let me, now that I have the email, the correct roster working, it should be a little easier to work with here. What the frick? Where's my stuff? Come on, go. Go. There it is. Okay. So that's not what I want. I want sent items. This is what I want. Boom. There we go. Okay. So I want to reply all. Why is it so hard on this thing? Okay. Let me open this up. Okay, let me reply all. Let me change the heading. Okay. Okay, so we're not covering chapter 2, we're jumping directly to chapter 3. Chapter 3 notes. These are the guided notes for chapter 3. Okay. Yeah, I'm sorry I didn't share this with you in the future. In the future, you'll have access to everything as soon as they register y'all for the class, which I don't know why we're in the second week and you guys still aren't registered with the school. But that's above my pay grade. So but you still nobody's officially on my roll as of yet. Still, this is unheard of. This is unfounded. It's never happened before to me. But I digress. Okay, so let me attach this file. Oops, wrong folder. Okay, I'm going to send you both this week's and next week's. Okay. So you should have both. If you don't receive it, please send me an email and say, I didn't receive it. You don't have my email, correct email address. Okay. So, there we go. Okay, I'm sending it now. Okay, so feel free to print this off. Is anybody gonna print this off? Does anybody want to print this off so that you can follow along? Why don't we take a 3-minute break? Let's take a 3-minute break. I'm gonna go get a soda, and I'll be right back. Okay, and I'll let you print that off within the next 3 minutes if you want to print it off. Okay. Okay, so let's do that. I'll be back in 3 minutes. I think I see myself going down that road right now. Okay, how are we doing? Everybody good? Whatever happened to chapter 2? Well, chapter 2 we don't cover because that's a chapter that's used for that's a chapter that's used for only if you're teaching elementary school. So we use the same book to teach a couple of different classes. So yeah. So just to let you know. Okay. Yeah, it's only if you want to be a teacher do you have to learn chapter 2. You're only teaching elementary school kids. Okay, let's move into chapter 3. Okay. Okay, sets. Okay. It is natural for us to classify items into groups or sets and consider how these sets overlap with each other. We can use these sets to understand relationships between groups and to analyze survey data, to analyze data, basically. Okay. Okay, basic definition. A set is a collection of distinct objects. Okay, called elements of the set. And we do an E like this. This means element. Okay, if you ever see that, this means element. Okay, a set can be defined by describing the context or by listing the elements of the set enclosed in curly brackets. So example of a set would be, say, 1, 2, 3. That's a set of 1, 2, 3. Okay. Those curly brackets, they also are called braces. Okay. Sorry, I didn't quite get that. What did you share? Okay, Professor, I don't know my screen, but the screen is really blurry. Oh, okay. Yeah, let me try to clean that up for you. Screen share. Okay, is that better? Hopefully that's better. And there is some lag going on here. I don't know where the lag is coming from, but it's definitely there. Oh, it's still not good. Let's see what I can do here to make it a little bit better. How's that? Let's see. Is that any better? Is that bad? Is that worse? Still very blurry. What the frick? Okay. Okay. Let's try this. Let's try one last time. Why would that be blurry? Everything's plugged in. Okay. Let's try it one last time here. Boom, boom, boom. Stop video, screen share. Sharing is caring. Okay, last time.
Way better.
Way better. Yay. Okay, it worked. Sweet. Okay, awesome. Okay, good. Perfect. Okay, so let's just define some examples of sets here. What would be the set of all even numbers? That's an example of a set. Now we could write that somehow, but it's just a set. It's just a set. Sometimes we just describe sets without the curvy brackets or the curly brackets or the braces. Okay, so the set of all even numbers, I could actually write that as starting with 0. 0 is considered an even number. 0, 2, 4, 6, 8, ... forever. Okay, to positive infinity. Okay, the set of all books written about travel to Chile, I can't necessarily write all those out because I don't know all of those. So how I represent that is just a circle. I say all books on Chile. Chile. Okay, so just represent it as a circle. Okay, we'll get to what that is later when we talk about Venn diagrams. Okay, some examples of sets defined by listing the elements of a set. Okay, here 1, 3, 9, 12. Red, orange, yellow, green, blue, indigo, purple. Those are examples of sets as well. Okay, notations of sets. Commonly, we use a variable to represent the set to make it easier for us to refer to that set later. The symbol E means is an element of. Okay, I already went over that. If the set contains no elements, then the empty set or the empty set is notated by a circle with a line through it. Okay, this is not a 0. Okay, this is a 0. This is an empty set. I'm just kidding. So when I write them, they're basically the same thing. But this is how are you going to know whether it's a 0 or an empty set? Well, if it's talking about a set, then it's empty set. Okay. Okay, let A equal A, B, C, D, E, F. List the elements of the set A. Use element to denote the elements of set A. Okay. So we would say, it says list the elements of set A. Okay, so the elements of set A are A, B, C, D, E, and F. Okay, and so we would say that these guys are elements of A. That's it. You just say these are elements of A. Okay, A, B, C, D, E, F are elements of A. Okay, A is an element of A. B, lowercase b is an element of A. C is an element of A. D is an element of A. Okay, E and F are elements of A. Okay, we could say that D, E are elements of A. However you want to, however you want to describe it, we can say multiple items are elements of A. One item is an element of A. Okay, some of the items of A are elements of A. Okay, a subset. A subset is a smaller set of the given values that we're talking about. Okay. Okay. B, if B is a subset of A, we write A, B is a subset of A. The way that we look at this is we say that let A be the set, I don't know, say 1, 2, 3, 4, 5, 6. And then I'm going to say, well, out of this, 1, 2, 3, 4, 5, 6, out of 1, let's just go 1, 2, 3. Let me write it like this. 1, 2, 3, 4, 5, and 6. And then we would say out of the set A, well, what might be a subset of this? Well, how about just the odd numbers? That would be a subset. So a circle inside of a circle. Okay, so this guy would be B. Okay, B here. B is a subset of A. Okay, so this guy is A. Okay, that's all of these items. So we would say that B, set A is a subset of what larger set? Okay, I kind of did it backwards here, but we could just say 1, 2, 3, 4, 5, 6. Okay, A is a subset of of this set. We could also say that maybe A is a subset of the odd numbers. Okay, so a couple of choices here. Okay, we could list a bunch of sets that 1, 3, 5 could be a subset of. Okay. So we could say, oh yeah, this thing is the odd numbers. That's the set. Excuse me. And then 1, 3, 5 is the subset. Okay. Excuse me. Okay, let's go over 3.2 here. Union, intersection, and complement. Okay, commonly sets interact. For example, you and a new roommate decide to have a dinner party, and both of you invite your circle of friends. At this party, two sets are being combined. Your roommate's friends and your friends, otherwise known as the union of both of your friends. Okay, so the union of both of your friends. So it would be your roommate's friends and your friends combined, right? Now, let's look at my roommate's friends. Let's look at my friends. Right? We'll call my roommate's friends group A and my friends group B. Now, it could look like this. What does this mean? That roommate's friends are group A and my friends are group B. What does that mean if they're disjoint like this?
There are two different sets.
They're two
Maybe.
different sets. Okay, what does that tell us about the friend groups?
I'm not sure.
No? do I have any of my roommate's friends?
No.
No. No, there's no shared friends here. Does that make sense? My roommate has his friends, and I have my friends, and neither the twain shall meet.
Oh, okay.
Does that make
That
sense?
makes more sense. Yeah, I missed that point.
Disjoint.
Thank you.
Yeah, sure. It's disjoint. What about this one here? What if we say this is group A and this is group B? Now what? Well,
Now they're together.
yeah, now we have Fred here. And what do we know about Fred?
You're both friends with them.
Yeah, I'm friends with Fred, and my roommate is friends with Fred. Does that make sense? Okay.
Yes.
So all of our friends together create what's called a union. We use this symbol U to designate red, yellow, orange, and purple. Find the union of B and the A union B and B union C. Okay. So I want to, now, I don't count an element twice. Okay. I don't count an element twice. I only count it once. So let's do A union B first. A union B. Okay, orange. Okay, orange is going to be part of the group A union B, right? Okay, orange. Okay, yellow is included. Red is included. Blue is included. Orange, I got orange again. Well, orange is included in both. That's like our Fred, right? Do I count Fred twice? Are there two Freds? No, there's not two Freds. There's just one orange. So I don't count it twice. Okay, brown. Okay, purple. Okay, and then green. Let me get rid of Fred here. And green. Okay, what about A union C? A union C, let's see what we got here. Okay, orange and orange, yellow and yellow. Okay, so those are the overlaps. Okay, and so red, oh, there's red too. Red and red. Okay, so those overlap. So I really only need to list out orange, yellow, red, blue, pink, brown, and purple. Okay, pink, brown, and purple. That makes sense? Okay, the intersection of two sets contains only the elements in both sets. Okay, so here we've got our sets again, but now we're interested in only what they have in common. Only what they have in common. Again, let's go back to this guy here. Let's look at A union B real quick. Okay, if we did A union B, right, that would be this set and this set. Okay, and for A union B, what was the only one that was what only one that they shared? That they shared an orange, right? So maybe orange there. Okay, we've got in A, we've got yellow, red, blue, right? Orange is in both. And then we have in B, we've got brown, we've got purple, and we've got green, right? I don't have to count orange twice. He just happens to be part of both groups. So this orange here is the intersection, whereas before the union was the whole thing. The intersection is the overlap, is what they have in common. That's the intersection. We say intersection, Okay, A intersection B. So what's A intersection B? Well, isn't that just going to be the one that they have in common? Yeah, it's a set of one item. Is this right? No. The sets are different. It's A. What are they asking me for? Oh, it's A intersection C, not B. Okay, let's look at A intersection C. Okay, so orange, orange. Okay, yellow, yellow. Okay, red, red. Okay, so yeah, so the intersection here is orange, yellow, and red. Orange, yellow, red. Okay, what about BC? B intersection C. Which ones do they have in common? Go ahead and type it in the chat box. Which ones do they have in common? B and C. Okay, what do we got? What do we got? What do we got? What do we got? Let's see what we got here. Okay, well, this is orange, brown, purple, orange, brown, purple, orange, brown, purple, orange. Okay, let's see what we got. Let's see. What's the overlap here? Okay, B, do they both have orange? Yes, they do. They both have orange. Okay, do they both have brown? Yes, they do. They both have brown. Do they both have purple? Yes, they do. They both have purple. Do they both have green? No. Do they both have yellow? No. Red? No. Pink? No. Okay, so yeah, B intersection C is just going to be orange. Okay, brown and purple. Okay. Okay, let's talk about the complement here. The complement of a set A contains everything that is not in the set A, not in A. Okay, the complement is notated as A to the C power or A prime. Okay, we say that that's A prime, not to be confused with Optimus. Okay, or a Prius prime, whatever. Okay, sometimes A prime, A complement, or the negation. This little thing here means negate, negation. Okay, it's not. It means a not A. Okay, it's not in A. What is not in A? Right, okay. So let's look at this thing here. We want to find the intersection of not in B with C. Okay, not in B with C. Okay, so maybe we should do I don't know, this one's kind of hard. Not in B. Well, what's not in B? Let's list out all the colors here. Okay, orange, yellow, okay, red, okay, a blue, okay, brown, purple, green, okay, green, what else we got? Pink, Okay, brown, we have brown. Yes. We have red, yes. Yellow, yes. Orange, yes. Purple, yes. I think that's it, right? Those are all the colors. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8 distinct colors here. Did I miss one? Pink, yellow, and red are not in B. Okay, perfect. Thank you. Thank you, Alex. Okay, so what's not in B? Okay, so not in B. Well, I don't want what's in B. So I'm going to cross off what's in B. What's in B is orange. What's in B is brown. And what's in B is purple. And what's in B is green. Okay, so yeah, yellow, red, blue, and pink are not in B. Okay, now, so I'm going to say B complement is yellow, okay, yellow, brown, no, yellow, red, blue, and pink are not in B. But I want to intersect that with C. I want the ones I want the ones here that are in C. Well, which ones are in C? Well, yellow is in C, red is in C, blue, no, I'm not seeing blue. Blue is not in C. Okay, pink is in C. Okay, so B complement intersects C is just going to give me these three colors, right? So yellow, red, and pink. And pink. Yellow, red, and pink. Okay. That's cool. Okay, what about the other one here? What about A intersect B, what about this one with B? If I intersect that with B. Okay, B, C intersect with A. Okay, so we already know what B complement C is. So which one is in B complement C and is in A? Okay, well, is orange in A? Or is orange in B complement C? No. Is yellow? Yes. Is red? So yes. Is blue? Yes. Is pink? No. So this is going to be which one is this going to be? It's going to be yellow, red, and a blue, right? Is that right? Okay, A, yellow, red, blue, and not in B is yellow, red, blue, and pink. So yeah, this is it. Yellow, red, and blue. Okay, make sense? Hopefully. You're confused? Okay. So let's try it over again. Okay. Okay. So think of all the colors in a box. We've got all the colors in a box. So we've got orange, we've got yellow, we've got red, we've got blue, we've got brown, we've got purple, we've got green, not queen, green. Okay. We've got pink, we've got brown, we've got red, we already have red, we have yellow, we have orange, we have purple, right? Purple. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 colors. We do not want the ones that are in B. So B complement C are the ones that are not in B. Well, which ones are in B? The ones that are in B are orange, brown, purple, and green. And so I don't want those ones. I'm throwing those out. So B complement C are the ones not in B. Okay, they're not in B. I don't want B. If I said that these things were B, if I said that what's in B? What's in B? Okay, in B is orange, brown, purple, and green. I want what's outside of B. I don't want what's in B. I want what's outside of B. Well, what's outside of B here? Yellow, red, blue, and pink. That's what's outside of B, right? We don't want B. That's what B complement means. We do not want B. We want all the stuff that's in the sample space, but not in B. So this is B complement. B complement. Now I need to intersect that. We'll intersect that with what? I want to intersect that with A and C. Okay, so let's do C first. Okay, which colors are in C? Well, in C is pink, brown, red, yellow, orange, and purple. So pink, I think that's pink, right? Pink, blue, and pink. Yeah. Okay. So which one of these are in C? Well, pink is in C. Okay, so that's good. Okay, brown is in C, but that's in B. I don't want that. Red is in C. Okay, so that's good. And yellow is in C. Okay, but blue is not in C, so I can't have that either. So I'm only left with pink, yellow, and red for for B complement C. B complement intersected with C. Okay. So maybe a diagram helps. Okay. Since everything from the color fuchsia to puppies and peanut butter are included in the complement of a set, notice that the example above, it would be hard to ask for a complement. Okay, what's a complement? No, it's everything, not an A, but in the entire set. Okay, a universal set is a set that contains all elements, including itself, usually denoted by U. The elements in the universal set is defined by the context of the given sets. Okay, so let's look at an example here. What might be the unit set for the given sets? Well, a set of books. Well, what might be the universal set? What might be a larger set that the set of books is a subset of? Well, a set of books. Well, how about all books in a library? That might be the bigger set, the universal set that this smaller set comes from. What about a set of friends on a social media site? Well, how about all friends, all your friends, on Instagram? Right, so you could have a set of friends. Maybe those are just your best friends, and that's a subset of all your friends. Okay, what about a set of numbers? A set of numbers, okay, this would be a subset, right? A set of numbers could be a subset, okay, of all real numbers. Okay, it could be a subset of all real numbers. So again, if we look at our diagram, we could have all real numbers here, and then a subset of that might just be some set of numbers, maybe just the integers, okay, or the whole numbers, okay, are a subset of all numbers, all real numbers. Okay. Okay, the complement of any set is relative to its universal set. Hence, A complement contains all elements in the universal set, not in A. Okay, so if the universal set is the numbers 1 through 9 here, and set A is 1, 2, 4, what are the pieces that are not in A? What are the pieces that are not in A? Okay, well, we just went through this. This would be the ones that are not, like, right? So if we said that everything is 1, 2, 3, 4, 5, 6, or let's do like this. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. And we said that A is 1, 2, 4. So A is 1, 2, 4 here. So this is set A. Then what are all the things not in A? Well, that would be 3, 5, 6, 7, 8, and 9. Right? All the items not in A. Okay, example 3.10. Let U be the universal set, 1 through 20. Let A be these guys, and let B be these guys. Find the following, A intersect B. Okay, find the following A intersect B complement. Okay, B complement. So we want all the numbers that are not in B. Well, the universal set are all the numbers 1 to 20. So let's just look at the numbers 1 to 20. Okay, the universal set are all the numbers 1 to 20. So maybe list out the numbers 1 to 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so we have all the numbers 1 to 20. Okay, and it says we want A intersect B complement. So we don't want the ones that are in B. So B complement are not in B. We want all the ones that are not in B. So let's get rid of all the ones that are in B. Okay, so 1 is in B, so get rid of that. 2 is in B, 3 is in B, 6 is in B, 7 is in B, 9 is in B, 11 is in B, 14 is in B, 16 is in B, 19 is in B, and 20 is in B. Okay, so B complement is what? B complement here is 4, 5, 10, 12, 13, 15, 17, and 18. 10, 12, did I miss up? Somebody's chatting with me. Okay, oh no, Alex just listed them out for me. Okay, so 4, 5, oh, 8. 8, yes, 8, thank you. Missed one. 4, 5, 8, 10, 12, 13, 12, 13, 15, 17, and 18. Okay, so that's B complement, but I want to intersect that with A. I want those in B complement that are also in A. Well, is 2 in both sets? No. 2's gone. Is 5 in both sets? Yes. Yes, 5 is in both sets. Boom. Okay, so A intersect B complement C. 5 is in both sets. That's good. Okay, what about 7? Nope. What about 8? Yep, both sets. Okay, what about 10? Yep, both sets. Okay, what about 11? Nope. Nope. No 11. Okay, nope. Okay, what about 12? Yep, 12 is in both sets. What about 15? Yep, both sets. Okay. And is that it? 16? Nope. 20? Nope. Okay, that's it. Yeah. So 5, 8, 10, 12, and 15. Perfect. Done. Okay, what about B intersect A complement this time? Ooh, spicy. We want all the ones that are not in A intersected with B. Okay. So all the ones that are not in A. Okay, so not in A. Let's just think about, let's go through the list and let's look at, is it in A? And then we'll ask ourselves, say yes or no. And then we'll just put the ones that are no. Okay, so is 1 in A? No. So 1 is a complement. Is 2 in A? Yes. Is 3? No. Is 4? No. Is 5? Yes. Is 6? No. Is 7? Yes. Is 8? Yes. Is 9? No. Is 10? Yes. 11? Yes. 13? No. Is 14? No. Is 15? Yes. Is 16? Yes. Is 17? No. Is 18? No. Is 19? No. Okay, so that's a complement. Now I want to know which one of these are the same as, have the same in common with B. Well, what's B? B is 1, 2, 3, 6, 7, 9, 11, 14, 16, 19, and 20. Okay, so which ones do we have a match on? We have 1s, we have 3s, we have 6s, we have the 9s, we have the 14s, and we have the 19s look like, right? So B intersection with a complement looks like we have 1, 3, 6, 9, 14, and 19, okay? Okay. Okay, so do you want me to email your homework for today and tomorrow, or for today and Wednesday now, or wait till Wednesday? Now, okay. Okay. Okay, then I will do that. I'll do that now. So you can start working on it now, okay? Okay. Again, not due until Sunday night. It's not due until Sunday night. Okay? But if you want to start working on it now, you can start working on it now. Okay, I'll email that right now. Okay? Okay. I'll send out the link to the next Zoom session on Wednesday morning. Yeah, the rest of the notes are for Wednesday. I mean, we're out of time for the class. So, yeah. Exactly. Okay. We'll cover 3.3 and 3.4 on Wednesday. Okay. Okay, I'll see you guys later.
Thank you so much.
Yeah, you're welcome.
Professor Holtman, quick question before I leave actually. So the numbers you're comparing, like let's say the last example, are you looking into the, like for example, you're looking into the question and you're comparing the sets, right? The numbers that you're gonna put together, if I'm correct, right?
Yeah, the universal set and set A and set B. I'm looking at those sets.
Okay. Okay, I just wanted to clarify. Thank you. Thank you so much.